Welcome to Healthy Living, Healthy Planet Radio, sponsored by EarthX, the world's largest environmental experience, and also sponsored by Natural Awakenings magazine. Live your healthiest life on a healthier planet. Now here's your host, Bernice Butler.
Welcome to Healthy Living, Healthy Planet Radio today. We are now beginning our fourth season, and we are just as excited as ever to continue to help you explore and understand that unbreakable relationship between your health and the health of the planet. Here we look at the hottest topics related to our environment and its sustainability and how they affect your health and wellness. Here, issues like climate change, plastic pollution, extreme weather events, and others will meet up with everyday impacts like allergies and asthma, digestive issues and gut health, cancers, lung, heart issues, and more. So listen in today as we begin our series this month on extreme weather events. And today we're going to focus in on wildfires and the droughts and the winds that seem to accompany them. Now, in the early 2000s, a new field of climate science research emerged that began to explore the human fingerprint on extreme weather events such as floods, heat waves, droughts, and storms. And they called them, or it was known as extreme event attribution, aka extreme weather events. The field has gained momentum, not only in the science world, but also in the media and the public's imagination. And the research in this field has the power to link, and indeed has linked, the seemingly abstract concept of climate change with our personal and tangible experience of the weather. That is what we see, feel, and experience each and every day in our weather. Scientists have published more than 400 studies looking at weather extremes around the world, all the way from wildfires in the U.S. and Australia and heat waves in India and Pakistan to typhoons in Asia and record-breaking rainfall in the U.K. and increasingly here in the U.S. The result is mounting evidence that human activity is indeed raising the risk of some types of extreme weather. A recent analysis of most of the extreme weather attribution studies that's been published reveal that 71% of the 504 extreme weather events and trends included in the study were found to be made more likely or more severe by human-caused climate change. They found that 9% of events or trends were made less likely or less severe by climate change, meaning that 80% of all events experienced some human impact. And then the remaining 20% of extreme weather events and trends showed no discernible human influence. Now, of the 152 extreme heat events that have been assessed by scientists, 93% found that climate change made the event or the trend more likely or more severe. And for the 126 rainfall or flooding events studied, 56% found human activity had made the events more likely or more severe. And then for the 81 drought events in that study, it was 68% that found that human activity made it more likely or more severe. Now, since 2000, though, the U.S. has experienced an average of 71,000 wildfires annually. And although these events do affect people's lives and economy, the environmental impact of wildfires is also quite significant. Billions of dollars and thousands of cleanup crews strive to restore the ecosystems and safeguard natural resources in the aftermath of a wildfire. Together, forests, shrubland, and grassland cover more than half of the land mass of the land area in the United States. And these ecosystems are important resources, both environmentally and, of course, economically. And although wildfires do occur naturally, and they do play a long-term role in the health of these ecosystems, changing wildfire patterns threaten and indeed are upsetting the delicate status quo. Multiple studies have found that climate change has already led to an increase in wildfire season length, in wildfire frequency, and the areas that are being burned. The wildfire season has lengthened in many areas due to factors including warmer springs, longer summer dry seasons, and drier soils and vegetation. Similarly, climate change threatens to increase the frequency, the extent, and the severity of fires through increased temperatures and droughts. Widespread wildfires in the summertime and now even springtime are rapidly becoming the new normal in the American West, and they are spreading beyond that. We here in Texas are experiencing our own. And along with the destruction and the loss of forests caused by these blazes, there are immediate and long-term environmental impacts that dramatically affect vital resources and our health. Wildfires are often caused, as we mentioned, by human activity or a natural phenomenon such as lightning, and they can happen anytime or anywhere. Now, in 50% of wildfires that have been recorded, it's not known how they started. According to the U.S. National Interagency Fire Center, humans do cause 87% of wildfires annually, usually after leaving campfires unattended, discarding lit cigarettes, and in some cases committing arson. The risk of wildfires increases in extremely dry conditions, such as drought, and enduring times of high winds. Wildfires can disrupt transportation, they can disrupt communications, they can disrupt power and gas services, as well as our water supplies. They also lead to deterioration of air quality, the loss of property, of course, the loss of crops, the loss of other resources, the loss of animals, and of people. Wildfire smoke is a public health concern in the western United States and increasingly in many other geographic areas here. Climate change is contributing to this increased risk and the extent of wildfires in our country. Wildfire risk depends on complex interactions between temperature, soil moisture, and the presence of trees, shrubs, and other potential fuels. And all of these factors have strong direct or indirect links with climate variability and climate change, and again, impact our health significantly. Now, this is a lot. But here today to help us understand this some more and to help us unpack this are two experts. Today we have Daniel Swain and Noah Diffenbaugh with us. Daniel is a climate scientist focused on the dynamics and impacts of extreme weather events, including droughts, floods, storms, and wildfires on a warming planet. Daniel holds joint appointments with UCLA's Institute of the Environment and Sustainability, and he's a research fellow at the National Center for Atmospheric Research, and he's also the California Climate Fellow at the Nature Conservancy. Daniel also authors the Weather West blog on climate. Welcome, Daniel. Thank you for being with us today, and that I get all of that right.
Yes. Thanks for having me. And I think you got it all right. It's a bit of a mouthful, so thank you.
Great. Our other guest is Noah Diffenbaugh. Noah is with Stanford's Doerr School of Sustainability. Noah studies the climate system, including the processes by which climate change could impact agriculture, water resources, and human health. He's also served as the lead author for the Intergovernmental Panel on Climate Change. That is the IPCC report. And we had some other authors of those reports with us on the last two shows. Welcome, Noah. And did I get all of that right?
Thanks for having me.
Great. And we just have a few minutes before we go to break, but I do want to start out in that time with Daniel. And to kind of start out at the beginning, Daniel, talk to us about what is the environmental or scientific definition of wildfire and what sets apart a wildfire from, I guess, tame fire?
I think it's a good question to sort of figure out exactly what we mean by wildfire in the first place. And I think something that has, in some circles, been forgotten over the years is that wildfire, as you mentioned in the introduction, is inherently a natural process. In most ecosystems on Earth, fire plays an important part of the ecology. So it's not that the fires that occur in vegetation, which essentially are what a wildfire is, any sort of unplanned fire burning primarily in vegetation. It's not that they're always a bad thing. In fact, they actually can be good things when they occur at a lower intensity and sort of with the frequency that they would have occurred naturally, in centuries and millennia past. But the challenge right now is that the wildfires we're seeing in many regions, especially in the American West and in places with similar climates, are becoming much more intense and having much more severe impacts, not only on the people who live in these heavily vegetated and potentially flammable environments, but also on the ecosystems that might otherwise have thrived under different sorts of fire conditions of a lower intensity fire.
So it looks like the key word here is planned. A wildfire is an unplanned fire, whereas the ones that are set deliberately or planned, I like to call those the tame fires, or not.
Yes, that's right. And we often call those planned fires in a contemporary context prescribed fire or controlled burning, sort of purposeful burning to achieve specific risk reduction outcomes or ecological benefits. There's also been a long history of cultivated purposeful burning by indigenous peoples all around the world for thousands of years. And that was actually an important part of North American fire history prior to the last 100 or 150 years or so, where a lot of those fires, as well as naturally occurring fires sparked by lightning or something like that, were suppressed. So part of the problem we're seeing, in addition to climate change, is that the background fire regime has been really disrupted from what it was for thousands of years. And so we've not only warmed the climate, we've also added more fuel to the fire as well.
Indeed, because when the fingers start pointing, we often hear that alluded to. We're going to go to break now, and we're going to come back, though, and finish talking about this definition of wildfires versus the prescribed or tame fires. Thank you. We want to give a shout out now to our sponsors. That is Natural Awakenings, Dallas-Fort Worth Metroplex Magazine, the green, healthy, and sustainable living authority for the DFW Metroplex and North Texas communities. Print issues of Natural Awakenings can be found in Whole Foods markets, natural grocers, Central Market, sunflower shops, and many, many other locations, as well as available free for download online at nadallas.com. Check them out. Our other sponsor is North Haven Gardens, serving the Metroplex since 1951, the most respected horticultural establishment in North Texas, offering gardening and plant education, concierge services, DIY classes, gifts, and more. Check them out at nhg.com. And our other sponsor is Lynn Dental Care, practicing dentistry for over 38 years with a holistic approach, looking at the whole body, non-mercury. Specializing in periodontics, Dr. Lynn is board certified by the International Academy of Oral Medicine and Toxicology. Check them out at lindentalcare.com. Thank you, sponsors. Welcome back to Healthy Living, Healthy Planet Radio, to today's show on extreme weather events, the first in our series this month. And we're focusing today on wildfires and the droughts and the winds that seem to go along with them. And we are back with Daniel Swain, a climate scientist with UCLA's Institute of Environment and Sustainability and a fellow at the National Center for Atmospheric Research, and Daniel Diffenbaugh with Stanford's Doerr School of Sustainability. Again, thank you all for being with us today. And before we went to the break, Daniel was helping us get a good working and talking definition of wildfires. And you were explaining that we've typically done I think you call them the control fires. I like to call them the tame fires. And I know that we often hear about that when fingers are pointing as to, especially when we started having the fires out west a few years back. And, the various parties were pointing fingers at each other. And I know that control burns and failure to do them came up. But let me ask you this. So is there ever a situation where the control burns get totally out of hand and they turn into wildfires, or a situation where the wildfires can be brought under control and then serve to do what the controlled burns do?
That's a good question. It does go both ways, but we tend to see a lot less of the former and more of the latter. So that is to say that every once in a while you do get prescribed fires or controlled burns that escape that control and become wildfires, and every once in a while cause some harm. We did see a pretty high-profile example of that in northern New Mexico with the Hermit's Peak fire. But that is pretty rare. That happens, I believe, less than 0.5% of the time during prescribed burning. So it's definitely a concern, but it's something that is quite rare in the broader scheme of things. On the other side, we often do see fires that can start unintentionally and become wildfires that can, in certain contexts, if the weather and the climate conditions are favorable and they aren't too close to highly populated communities that would be at risk, you can manage those unplanned wildfires for ecological benefits and even risk reduction benefits, moving forward. So there are different entities that manage fires like that. The National Park Service does a really good job managing a substantial fraction of the naturally ignited fires. So mainly, fires started by lightning in the forests in the West, and to some extent letting them burn within certain bounds, of course. That's actually a pretty common practice, and it does lead to improved outcomes in that case. So there's a lot of complexity with fire. It's certainly not all bad. It can have benefits, but it can definitely also have harms, and we've certainly seen that side of things pretty dramatically over the past decade or so across a lot of the western U.S.
So why is wildfire considered a weather event?
Well, there's really two reasons. The fires themselves are very responsive to short-term weather conditions. So you can imagine, for example, if you've got a wildfire or a potential wildfire burning somewhere, and it's cool and damp, that fire is not going to behave anywhere near as dramatically as if it's hot, dry, and windy, for example. So that's a pretty obvious, comparison between a drizzle and a dry, hot windstorm. You're going to have a much faster spreading, hotter burning, and much more difficult to deal with fire, if it's hot, dry, and windy, for example. But also, the weather and sort of the climate, if you think about weather over the long term, matters in terms of what it can do to the vegetation itself, because, of course, in a wildfire, it's mainly vegetation that's burning. And if it's excessively hot and or dry repeatedly over weeks and months and years, you're going to dry out that potentially flammable vegetation a lot more than you would have had it been cooler or moister. And this is sort of, as we transition into talking about the climate change component of it, this is one of the big stories, is how a warming climate, especially in places like the western United States, is acting to progressively dry out the vegetation, the forests, but also other ecosystems to an even greater extent than they would have experienced historically. And so that sets the stage when you get those extreme weather events. So say you get a big wind event, if the vegetation has been pre-baked, if you will, for months and months by record warmth and record dryness, it's going to burn a lot more readily and a lot more intensely when that extreme weather event, when that wind event, or when that heat wave comes than it would have otherwise. And that's sort of the way we think about the interaction between fire and weather and climate.
So would you say, or can we say, or can we think about it in terms of, in order to have a wildfire, you have to have drought and wind?
Well, not necessarily. I mean, you can certainly get fires under somewhat less dry conditions, but I think it's fair to say that if you have very dry conditions, as you would during a severe drought, or if you have very windy conditions, as you would during an extreme weather event, you're going to get a very different fire than you would have under other conditions. One that might even go from being perhaps under calm weather conditions and no drought, maybe even net beneficial, to being one that under extreme drought conditions and high wind conditions could be very destructive.
Yeah, they drive wildfires. And I wonder if there's been any statistics as to look at that prevalence, I guess the prevalence and severity of droughts and winds in the wildfire. Because it does seem to me that without the drought, which means you got something like the rainforest, it's going to be hard to start that fire. And then the wind is what's driving it and making it, quote, wild. So it certainly those are big drivers. Are there any statistics, though, in terms of the effects of those two on wildfires?
Yes, I mean, when that there has been research on both of these things, And, when we make that connection, it's really clear that you get more severe, larger, more intense wildfires during droughts than during other times. And you also, independently, get faster spreading and more destructive fires under high wind conditions as well. So they're both sort of independent factors. They can be additive, though. So if you've got both lined up, that just really amplifies the situation.
Yeah, because I would think without the wind, it would be much easier to control it and the fire wouldn't get wild. Noah, let me ask you if you can weigh in on that too. Any studies or statistics that you might know of that document or that go to inform this effect of drought and wind?
So there's been a lot of research, and one example, a study that both Daniel and I were co-authors of in 2020, we analyzed the autumn wildfire conditions in California, and that's when in recent years we've seen a number of very destructive fires, in particular multiple fires in far-flung parts of the state that have really stretched the firefighting resources. And in that study, we documented that the most extreme wildfire weather conditions, so the combination of low precipitation, high temperature, strong winds, low humidity, the days that had the most extreme combination of those weather conditions, those have been responsible for about twice the area burned during the autumn season in California compared to all the other days. So I think it's important to distinguish, what causes the most severe conditions versus what causes wildfire at all. So we see wildfire all around the world. We see wildfire in rainforests. Mm-hmm. We see lots of wildfire in the Arctic. Fire occurs all over the world. And what we do see consistently is that, the most severe fires do tend to occur in these amplified weather conditions in combination with the other kinds of factors that you all have been discussing in terms of, the history of fuel suppression, the availability of resources for responding. So I think it's important to emphasize that it's not, fire or no fire. It's really a question about risk.
Indeed. And we just have a couple of more minutes to go before we go to break. But there's two things I want to talk about, and we won't get to talk about them both before the break. One is, given this information and these studies that have been done, seems like to me you all might be able to now or in the future be able to perhaps project where wildfires might be coming, which is helpful. And then I want to talk about the wildfires in the rainforest and the Arctic, which are wet places. So how does that happen to have the wildfires in the rainforest? Because it's wet.
Well, yeah. So, certainly the Amazon fires have been in the news and the public consciousness a lot in the last few years. And, it's important to note it doesn't rain all the time in the tropics. So we see, fires not just in the Amazon, but also in tropical Africa and Indonesia and other places that are wet in the mean. So one important point is that it's not wet all the time. Another is that humans start fires. And, we've certainly seen with these, in the Amazon, it's been documented the contribution of the human ignitions, right? So intentional burning,
the arson,
has been a contributor. But it's also important to note that we get a lot of weather variability as well.
Indeed. Thank you. We'll be right back on the other side. I appreciate that explanation, Noah, too. We'll be right back on the other side of the break with Daniel Swain, UCLA's Institute of Environment and Sustainability, and Noah Diffenbaugh with us. Stanford's Doerr School of Sustainability. Welcome back to Healthy Living, Healthy Planet Radio, to today's show on extreme weather events, focusing in on wildfires with droughts and winds. And we are back with Daniel Swain, UCLA Institute of Environment and Sustainability, and Noah Diffenbaugh with Stanford's Doerr School of Sustainability. And again, thank you all for being with us. Now, before the break, Noah was helping us understand somewhat why and how we get the wildfires in the rainforest. What about the Arctic? I guess it can be dry, but it's still wet and frozen wet. How do wildfires get started there?
Well, I think, first of all, the idea is important to understand that there isn't a place on Earth that's the same all the time, right? So there's a lot of variability, both wet and dry and hot and cold, and that occurs during the year as the seasons change, and it also occurs from year to year with what we call climate variability. And certainly, I'm sure listeners have heard of El Nino.
Yes.
And, that variation, the El Nino Southern Oscillation. And so, that's really a really strong cause of variability in climate around the world, and particularly in the tropics. So there's been a lot of research on fire and smoke in the tropics, and El Nino plays a really big influence. Conditions in the tropics tend to be hot and dry during the El Nino years, and that has been associated with burning in the tropics. And then in addition, as I was saying earlier, people start a lot of fires, and there's a lot of land clearing, and even government policies and enforcement of policies play a strong role in how much burning there is in not just in the tropics but around the world.
Indeed, it seems like we've got this people problem also as part of our extreme weather events. Now, you had also mentioned earlier, Noah, kind of about the components that go into wildfires, which made me wonder, do we have the ability to project or perhaps estimate where wildfires are going to be coming and when? By looking at weather. The weatherman comes and it tells us the weather and the rain is coming and all of that stuff. So we know a number of those weather-related components and when they're coming and where they're coming. So what do we know, and does that allow us the opportunity to project where wildfires might be coming so people can be on the alert and perhaps control them more?
Yeah, so first and foremost, it's important to remember that, like other extreme events, wildfires result from, multiple different conditions coming together. And, certainly it takes fuel, right? There has to be something to burn. It takes ignition, right? The fire has to start. And then, the weather also, is an important component. And there's been a lot of research into each of these. And certainly for the weather, there's the weather conditions. There's been a lot of research into what weather conditions tend to elevate wildfire risk. And so, there are a lot of studies analyzing both the historical changes in those weather conditions, like the temperature and precipitation and winds and humidity. And there's been a lot of studies projecting out into the future, which areas may experience emergence of new wildfire weather regimes. So, like many aspects of the climate system, the kinds of events where we see a strong influence from heat in particular, we see elevated risk as global warming continues, right? So, because the vegetation is so sensitive to hot conditions, all else being equal, the continued warming is likely to amplify risk in the areas that already experience wildfire.
Well, I'll give you an example. I have heard from time to time on the news, they talk about the Santa Ana winds in California. And I've heard some warnings there. So are they able to tell when those winds are coming? And then they know that it's been dry and that the fuel is prime. And I have to think that they have some systems they can overlay on each other that may be able to tell us that.
Yeah, so I'm interested in Daniel's answer here because Daniel's a real expert in these questions. I think I'll just say first that we have the short-term forecasts, of what's likely to happen in the coming days or weeks, in some cases even the coming season. Mm-hmm. And then we have the longer-term risk assessment, the longer-term climate change. And, Daniel's thought a lot about both of those. I'll just say in terms of your question about the winds and the other factors, Daniel had a really nice commentary on this a couple of years ago and really laying out how for the long-term climate change, even, the winds are so important, but even with no change in the winds, just the long-term warming will tend to increase the odds that the dry vegetation is in place when those strong winds blow. And then, of course, ignition really matters, right? So having all those conditions come together really is what creates the risk.
Indeed. So, Daniel, how can we tell, and do we know when the wildfires are coming, or we suspect it, so we can be on alert and maybe control them more?
Well, as we've been talking about, wildfires are strongly linked both to the long-term climate conditions and also the short-term weather conditions. And we can predict both, but there are different kinds of predictions. When it comes to short-term weather forecasts, we're talking like weather for tomorrow or 3 or 5 days in the future, that kind of thing.
Mm-hmm.
We have pretty good weather forecasts these days, and we therefore have pretty good, you might call them fire weather forecasts. So we can, for that component of wildfire risk, we have pretty good predictions, sort of as we do, weather forecasts. You might hear that there's a 30% chance of rain tomorrow, and you might bring an umbrella. We tend to rely on these sorts of short-term weather forecasts for other things, and increasingly, that's an option for assessing that component of wildfire risk. But it is only one component, and I think that's the tricky part, is that there's a predictable component of wildfire risk and there's sort of an unpredictable component. We can do a pretty good job of predicting the weather, but as Noah mentioned, it's more difficult to predict exactly where an ignition is going to occur. In other words, where exactly is there going to be a spark that could potentially become a wildfire, irrespective of the weather conditions. Now, if we just sort of know that we can't predict those sparks that well, but we can predict the weather, we can at least say, well, if there is a spark, it's going to be a problem today. And so there are these things that we want to do to, either minimize ignitions, minimize those potential sparks, be really careful on these days in particular, or, as you've suggested, pre-positioning firefighting resources. This is something that now happens in California on a regular basis, where the state firefighting agency, CAL FIRE, and the federal, the Forest Service firefighting agencies all throughout the American West, they will allocate resources geographically based on weather forecasts.
And what type of weather forecasts cause them to, say, put the fire departments and the fire trucks on alert? That's what I'm trying to get at. What is the thing that allows them to project that we need to be on alert?
Well, it's the same way that we can, it's exactly the same way that we predict other kinds of weather, whether it's hurricanes or storms or heat waves. These mathematical models that describe the physics and the chemistry of the atmosphere. So, these run on these big supercomputers. These are the primary tools for weather forecasting. They also help us understand, day-to-day variations in fire risk. And in the long term, we're talking over decades, as the climate warms, similar but somewhat different kinds of mathematical tools known as climate models, still based on the physics and chemistry of the world we live in, help us understand, how much warmer it's going to get, or shifting precipitation patterns, or shifting humidity patterns, which is particularly important for fires. And so, in that way, we have both really good short-term predictions of days where there might be very high fire risk, and we can also assess our long-term trajectory over decades, understanding that in many places the risks highly favorable for fires are increasing.
Yeah, indeed. And it is helpful to know that just like when the weatherman is telling us we've got a thunderstorm coming or we've got snow or whatever, so that we can adequately prepare, that we do have a little sense of being able to project that. And I imagine the weatherman says, quote, conditions are ripe for a wildfire or something like that. And we just have about a minute or so to go before we go to break. And so, Daniel, I want to stay with you. What are, and really to get some input from Noah on this too, why are wildfires more prevalent in some parts of the country and the world than others?
Sure. So there certainly is, scientists would call spatial variability. I want to emphasize there's less difference between different parts of the country than it may appear, right? So the attention that gets paid is very different in different parts of the country, and certainly California and the western U.S. have been in the media and the public mind in recent years. But, the southeast of the United States actually, has annual fires that, are very consistent on a year-to-year basis. My point being that, fire happens all around the country and all around the world.
Indeed. Thank you. We're going to go to break now, and we'll be right back on the other side to talk to Daniel more about this why some parts of the country are experiencing more prevalence of wildfire than others. Thank you. We'll be right back on the other side. We want to give a shout out now to our sponsors. That is Natural Awakenings, Dallas-Fort Worth Metroplex Magazine, the Green, Healthy, and Sustainable Living Authority for the DFW Metroplex and North Texas communities. Print issues of Natural Awakenings can be found in Whole Food markets, natural grocers, central markets, sunflower shops, and many, many other locations, as well as available free for download online at nadallas.com. Check them out. Our other sponsor is North Haven Gardens, serving the Metroplex since 1951, the most respected horticultural establishment in North Texas, offering gardening and plant education, concierge services, DIY classes, gifts, and more. Check them out at nhg.com. And our other sponsor is Lynn Dental Care, practicing dentistry for over 38 years, non-mercury, with a holistic approach looking at the whole body. Specializing in periodontics, Dr. Lynn is board certified by the International Academy of Oral Medicine and Toxicology. Check them out at lindentalcare.com. Thank you, sponsors. Welcome back to Healthy Living, Healthy Planet Radio, to our first show this month on extreme weather events. And today we're talking about wildfires with their attendant droughts and winds. And we are back with Daniel Swain from UCLA and Noah Diffenbaugh with Stanford's Doerr School of Sustainability. Again, thank you all. You are indeed making us smarter about all of this. Now I want to go to Daniel when we were talking about why wildfires are perhaps more prevalent in some parts of the country and the world than others. And I hear you saying that it's a lot about the attention that they get. And I remember I lived in Florida for a number of years, and we had a different type of fire. We had the peat fires. It was different for us this year, too, in Texas when we had wildfires out west, and some even came to the edge of the Metroplex. And we weren't accustomed to that. So, Daniel, if you can talk to us a little bit about what you see, your research on why some areas get more wildfires than others. And does that mean that just about every place or any place can look forward to wildfires in the future because of the impacts of climate change?
I think it's a really good question, and there's a lot of interesting research baked into it. But I'll start with the general answer and then maybe talk a little bit about the exceptions, since they're kind of interesting. I think, in the U.S., in the continental U.S., there is more focus on fires out in the American West for good reason, which is that there are more fires in the American West than there are in the East. It doesn't mean they do not happen elsewhere, but they are a lot more common out West. And the main reason for that, there are a lot of reasons, but the number one reason really is that the climate is significantly more arid, and there is a really well-defined dry season that aligns in many cases with the warm season. So you think in the eastern U.S., you get a lot of rain in the summer. You get thunderstorms, afternoon downpours, you get hurricanes, things like that. In a lot of the West, it doesn't rain very much during the warmest time of the year, and so you have that warm season that coincides with things being extremely dry. And then in some places, you have a wind season that immediately follows that warm and dry season every single year. So in other words, there's sort of a seasonal drought that occurs naturally just every summer in a lot of places. You don't even need to have a long-term drought. You just have this sort of built-in one out west. So you often reach that dry threshold that you need for fires to spark easily. I mean, I think some folks, in the East don't actually have a hard time conceptualizing just how easy it is for a spark to lead to a fire in the West. Sometimes you get a spark, it's got about a 1 in 3, 1 in 2 chance of starting a fire out West. That's not how it is in the East. For example, California's largest wildfire for a while was sparked by a person hammering a stake into the ground. Nothing wild, not even a power tool, just a hammer. But that was enough to generate that spark under really dry conditions. You can, though, get fires elsewhere, and the reason for that is, as Noah mentioned, it sometimes still gets dry enough in other places, and that includes the southeastern U.S. Florida, you see fires, as you mentioned, in the swampland, sometimes occurring right above the water because the vegetation itself got dry enough. The largest, the most destructive wildfire in American history remains one that occurred, believe it or not, in Wisconsin, Great Peshtigo Fire in the 1800s. not where you would have expected, but a massive forest fire that occurred in that part of the country. So fires there are not nearly as common as they are in California, but they can certainly happen. And, one of the other big fire risk regions for what's known as the wildland-urban interface, where you have the potential for wildfires, but also lots of people living in potential harm's way. Central New Jersey, of all places, near the Pine Barrens. So imagine seeing a major wildfire from a skyscraper in Manhattan in the distance. That's, something that's not unlikely in the future. And this past summer, destructive wildfires within the city of London, England, for example. Not common, probably won't happen every year, but clearly possible because it just happened. And so the point being, if it's warm enough and dry enough in any given location, you got a significant amount of vegetation, you could have wildfires. And historically, some of these places didn't see those really dry conditions very often or at all, but increasingly, they are. And that does mean, as you suggest, that the potential for seeing major fires, at least conditionally in some years, is expanding a lot.
Indeed. The potential for all of us to see them, it's coming for us all. Thank you for giving us such a really great, easy to understand explanation of a lot of those components that go into it. And I think it does cause us to realize that it can be coming for us all because of the warm conditions and the other additives. And that's what global warming is all about. And climate change is driving all of that and exacerbating all of that and making the great potential for all of us to be affected by wildfires to be even greater. Because I know here in North Texas, we saw it coming into, it's kind of like you said, that ex-urban area out in West Texas, but it was coming into the city, the edges of the city as well. And a lot of it is because of our extreme heat and dryness. And all of us, all parts of the country can experience that with climate change. So we have to be concerned. And that leads me to my next question, Noah, and that is, I want to talk about briefly the health impacts of wildfires, which are most persistent or the most persistent. And then why should those of us who are not close to fires, why should those of us who are not close to them care?
Yeah, so certainly the most direct health impacts of wildfire are the fire itself. And, tragically, there are lives lost every year to, the burning from the wildfires. There also, we've seen then the indirect effects, and certainly the most pervasive of those has been the smoke from the fires, and that is increasing. That's been documented. The extent of the smoke, the persistence of the smoke, and the number of people affected by the smoke has been increasing. And there are estimates, that in recent years in the western U.S., the smoke from wildfires has undone years of progress on air quality, and just to give you a sense of the scale, anywhere from 25 to 50% of the particulate matter annually, is now contributed by wildfire smoke in recent years. So it's a health issue that's affecting millions of people. And that goes very, very far. That smoke literally goes very, very far. And, we often see reports of the sunsets, in the East Coast being affected. I think we're still getting an understanding of the health impacts from these far-flung smoke events.
I also have to think that people are beginning to realize, just like we get weather warnings some days in the summer about this Saharan red dust, and then we can see it coming over, and it's coming all the way from Africa. So I have to think that the particulate matter, the smoke, the smog travels from California over to New York and down to Texas and Florida even quicker. Do we have any sense of how quick that travels, how much of it travels?
Yeah, it travels in the atmosphere, and we're able to, scientists and the U.S. government, for the U.S. air quality are able to track that transport. And, I personally, during the times we have wildfires, I go to Daniel's Twitter. I don't have a Twitter login. I don't have an account, but I'm able to see Daniel's tweets publicly available. And that's, That's where I go to find the smoke projections, because Daniel usually is updating those when the fires are happening. And you can see the plumes of wildfire smoke following the winds, the prevailing winds, and traveling very long distances, including all the way across the U.S.
So, Daniel, are you able to tell us this smoke from the fire is going to travel 300 miles? It's going to travel 200 miles. You'll be seeing it in South Florida by day after tomorrow, or what? How does that work?
Yeah, I mean, the smoke from wildfires can travel actually even farther than that, not just hundreds of miles, but thousands of miles, and in some cases can more or less circumnavigate the northern hemisphere. I mean, there were people a couple of years ago when California was seeing very severe fires with smoke plumes that were reaching all the way up into the stratosphere. There were people in Western Europe who were reporting smoky sunsets and yellow and orange skies from those fires in California. So really, wildfires in a certain sense are local and regional events. They can have global impact.
Last questions for both of you all. We only have a couple of minutes to go. To you, Daniel, first, what can people do to help drive solutions in their everyday lives?
Well, when it comes to wildfire, this is sort of an interesting one because there's sort of a wide spectrum of things. If you're worried about the fact that climate change is increasing the conditions favorable for, extreme burning conditions and really destructive fires, then, the solutions you'd want to pursue there are the same for dealing with climate change in general, which is, we need to globally bring carbon emissions to near zero as fast as possible to solve the underlying problem. But with wildfire, there are additional things, I think, at local and regional scales that are really important because, the most direct effects of fires are at local and regional scales. So thinking about, how can we use more purposeful burning, prescribed fires, tame fires, that as you call them, to sort of reduce risks and improve sort of the background conditions. How can we design communities so that they're more fire resilient, so that we don't have these really destructive fires that burn hundreds or even thousands of homes in a single day? So there are these sorts of things you can do at a local scale as well as these broader global things to solve some of them.
Indeed. Thank you. Last word, Noah. Is there any way we can prepare ourselves for wildfires now and in the future?
Yeah, well, there's lots, as Daniel was saying, certainly the amount of global warming that we have will influence the amount of risk over the long term. How and where we build in terms of land use, is a key factor over the long term. And then, locally, within communities and around homes, defensible space and home hardening, planning, for response. And then lastly, I'll add, the resources available are really important. And in recent years, when we've had these really catastrophic large fires, often there simply haven't been enough resources available simultaneously to deal with all of those fires at once. So the investments that we make as a society in preparation and response are critical as well.
Indeed, thank you. And that's where, listening to the research and what we know from smart people like you pays off so that we can be ready in some cases. So thank you. We've been with Daniel Swain from UCLA's Institute of Environment and Sustainability and Noah Diffenbaugh with Stanford's Doerr School of Sustainability. And they have made us smarter today. Thank you all so much for being with us today.
Thank you. It's been a pleasure.
Thank you. Thank you, listeners, for listening in today to Healthy Living, Healthy Planet Radio. The conversation starts here, but our goal is to have it continue in your homes, in your social circles, your workplaces, at the water cooler, and in the grocery checkout line, so that we can all work together to realize that healthy living is simply not possible without a healthy planet. Our culture is the result of 1 trillion tiny acts taken by billions of people every day like yourselves. And each of those tiny acts can seem insignificant, but all of them add up, one way or the other, to the change that we each live through. This is your host, Bernice Butler. Thank you for listening in today, and listen in again next week as we continue our conversation on various extreme weather events. And you can listen to any of our past shows on podcast wherever you get yours. Thank you.